All right, folks. Good morning, good afternoon, good evening, depending on when you're watching this video. So hopefully you still have your guided notes in front of you. Otherwise, you kind of got a lot of writing to do. Let's go ahead and look at what two-way tables are. Don't make this harder than it needs to be. A lot of this is just going to come down to memorizing what goes where, and then just kind of looking at how to read the probability from there. So if you felt comfortable with the probability coming from a table from our 10.2 stuff, you're fine. That's basically all you're doing. You're still just looking at that specific probability. Some of it is just going to come from a different place, and it's something that you just have to flat out memorize, okay? So basically it's still reading a table and putting together probability, okay? So keep that in mind. All right, so the first thing that we want to talk about with this two-way table is exactly what that is. So a two-way table is what you're going to fill in first. And this table displays the same exact information that you would see in a Venn diagram, okay? So it's kind of how everything relates in one nice little place, okay? So in the table, we've got one category that is represented by the rows and the other that is represented by the columns. Okay, and hopefully you know the difference, especially since we already dealt with matrices and you know the difference between a row and a column. Okay, so let's look at this Venn diagram here. And I'm going to scoot this up a little bit. Okay, so you got this Venn diagram here, and you see how things relate. So they surveyed 80 students total. So if that's the case, if you know that total, go ahead and put that in the very, very, very last box that you possibly could have. Okay, that's the overall total of everything. Okay, and then take this Venn diagram and just fill in the table. So you know that 25 students out of this 80 play an instrument. So where does that 25 go? Well, you go under the play an instrument column, but then what is it not? Okay, the 25 is just playing the instrument and not speaking a foreign language, so it goes there. Okay, and then if you look at the other circle, the students surveyed who speak a foreign language, so they speak a foreign language but do not play an instrument, that 30 goes there. Hopefully that makes sense. And then the overlap between the two circles are the students who speak a foreign language and play an instrument, so that 16 goes in that very first box. And then that last little number 9 is not in anything. So they do not speak a foreign language and they do not play an instrument. Okay, so there's how you fill out the first part of your two-way table. Okay, and then obviously add everything up. So this total for playing an instrument is 41, not playing is 39, speaking a foreign language is 46, not speaking a foreign language is 34. Okay, so that's taking the information from the Venn diagram and filling it into the table. Okay, so hopefully that makes sense. I'm going to scoot this up a little bit. Okay, so take a second and fill out the corresponding table here. So answer the left-hand side first with how many students, and then we'll look at the probability. So take a second, read the table, fill in those numbers. Okay, so hopefully that's pretty straightforward in that, that's all in there. How many students play an instrument? Well, that's 41 total. How many students speak a foreign language? That's 46. How many students play an instrument and speak a foreign language? That's 16. How many do neither? That's 9. And how many play an instrument but do not speak a foreign language? That's 25. So now, filling in the probability, all you're going to do is take that number, so the first one would be 41, and then put it over one of your totals. That's where you have to pay attention, okay? It's not always going to be 80. You got to figure out what total that you're using. So the first one, how many students play an instrument, that's the only thing that they're asking. So it's just 41 out of the total. So 41 out of 80. Nothing else. Done. Okay? Now, how many students speak a foreign language? That's the only thing that they're asking. So that's just 46 out of 80. But go ahead and reduce that. So that's 23 out of 40 because you can cut both of those in half. Okay? And then the other thing we need to do is figure out from here, okay, so it says how many students play an instrument and speak a foreign language. Well, that's 16, right? 16 out of 80 because it's a total, right? I'm not manipulating this just yet. So we're sticking with just the overall total, 80. Well, what does that reduce down to? Isn't that 1 out of 5? Okay. And then the next one, again, even though we're looking at two different things, they do not play an instrument, they do not speak a foreign language, that's still just one number. That's 9 out of what? Out of 80. 9 out of the total. Okay, and I can't reduce that. And again, the last one, it's just 25 that play an instrument but do not speak a foreign language, and it's 25 out of what? 25 out of 80, which reduces down to 5/16. So hopefully you have a calculator handy, and you're going through this with me to verify, first off, I didn't make a mistake. And then second off, you know where I'm getting these numbers from. Okay, so please do have your calculators out to verify this stuff as I go. And then what I want you to do as we go through this video, as you go through these notes, I need you to put some stars down. Star the stuff that you have a question about. And make sure you write that question down so you can ask that next time we're in class, okay? Because with these 2A tables, yes, they're easy, but sometimes you can miss a little step, which throws off the entire problem. So just make sure you put little stars by the things you have questions for, and even write down those questions, okay? All right, so let's go through some vocab here. So a 2A table, you've already seen one. Okay, a 2A table is a frequency table that displays data from one source, but it belongs to two different categories. And you saw that from before. You have two different titles there on each of those tables that we looked at. Okay, so now when we're talking about the individual frequencies, a frequency is just the data that you're collecting. So typically in an experiment and what have you, you typically see these frequencies as like tick marks and then they tally them all up. Well, we're just avoiding that specific piece of this data collection, and we're just saying the numbers are your frequencies. So when I talk about frequencies, I'm talking about the numbers, okay? So you got to keep this stuff straight. So the joint frequency is each entry in your table. So all of those numbers previously, the 41, 46, 16, 9, and 25, those are your joint frequencies. Okay? Joint frequencies, those are your individual numbers. Now, the difference between a joint frequency and a marginal frequency, this is the sum of the rows and of the columns. So two different things. Okay, so what I like to think about, the joint frequencies, I'm looking on the inside of my table, and the marginal, I'm kind of looking on the outside, on the outskirts of the table. So if I go back here, oh, I don't have it on this slide. Sorry. If I go here, these are my joint frequencies, and these are my marginal. Okay, so do you see inside versus outside? So the inside numbers, outside numbers, okay? So you got to keep those straight. And obviously pause this at any point if I go too fast, please, so you can get the stuff recorded. Here. Okay. So those are the individual pieces of the table, but now what we're going to do is put some stuff together. We're going to put our fractions together, basically starting to get our probability. So joint relative versus marginal relative. When you see the word relative, think fraction. Okay? You will always put together a fraction or a ratio. So the ratio, again, you can also think fraction, of a frequency that is not in the total row or column, and you're going to compare that to the total number of values or observations. So basically the overall total, okay? So you're putting together a fraction of the numbers that are not part of your sums. So basically the inside, the middle, okay? So that's kind of how I think of it. The middle numbers divided by overall total. Okay? So you got to keep that straight. The joint relative frequency is taking the middle numbers where your joint frequencies are, the middle numbers, and dividing it by the overall total. Okay? So marginal relative frequency is going to be very similar. Okay, so you're still doing the ratio of the sum. Okay, so like before, fraction, but now we're going to put the joint relative frequencies in a row or column. Okay, it's going to make more sense when we put it together, and you'll see that in a little bit. Okay. All right, and then fill out the conditional. That is the ratio of a joint relative frequency to the marginal relative frequency. So it's basically taking what you did above and putting it together in one fraction. Okay? So to me, it makes more sense just to dive right into one of these problems to see all of that, okay? All right, so looking here, we have to, and a lot of these you're going to have to put the table together. So you got to be careful how you put everything in, how you organize everything, okay? So let's read this. You randomly survey students about whether they are in favor of planting a community garden at school. Of the 96 boys surveyed, 61 are in favor. Of the 88 girls surveyed, 17 are against. Let's put that together in a two-way table. So first up, we'll start with the response. And in fact, I'm going to move this over just a little bit. Okay. So these were the ones that were in favor. These were the ones that were against. And I'm going to get a total. Okay? There's your first stuff. First row, first column, set up. Okay, so then over here, I'm gonna write sideways, we'll see how this goes. Here's your gender. Okay, you understand the response and the gender are just your titles of the rows and the columns. You don't necessarily have to have those in boxes, but you do need the titles. Okay, so we've got boys that were surveyed, and then we've got girls that were surveyed, and then we've got our total. And then just fill in your box here. Okay. All right, so I'm looking up here. Go right here. So it says, of the 96 boys surveyed, that's the total. Put that down for boys. 61 are in favor. So that 61 goes there. So subtract. How many does that leave for against? That leaves 35. Okay. And then of the 88 girls surveyed, that goes there for your total. 17 are against. So that goes there. Subtract, leaving you with 71 that were in favor of that. And then just add up all your total. So 132 for in favor, 52 against, and if you add those, 96 and 88, 132 and 52, those should total 184 both ways. Okay? So there's your 2A table put together. And then it says, then find and interpret the marginal frequencies. Okay? And I do need to take a step back. I lied on something over here. We do not need the ratio here. This is just the sum, sorry. We're going to erase that from before. Oops. So when it says to just interpret the marginal frequencies, you're just explaining the totals. I got ahead of myself with saying the ratio. So the marginal frequencies here, just write out what everything is. So you've got 184 students surveyed. And then you've got, break that down into the 96 boys who were surveyed, and then the 88 girls that were surveyed. So you kind of have two subcategories under there. And then you just tell me what the 132 was. So 132, just put were in favor. And 52 were against. So if it asks you to explain or to interpret the marginal frequencies, just tell me what those totals were for. Okay? So just tell me what those were for. Okay, so take a look at that. Let me know if you have any questions on how we put that table together and then what it means to just interpret the marginal frequencies. Okay? Next up, let's complete this one. So we gave you a 2A table. It's kind of nice when we don't have to draw it. We just need to fill this in. Okay? So where to start? Well, if I've got a total of 130, I can go ahead and subtract the 60 for the people who took the city bus and subtract to get 70 who walk. And then that helps me get on time people who walk, it's 48. Well, then that'll help me with the city bus on time, that's only 10. And then the city bus, that'll help me to see 50 are tardy. And then I've got a total of 72 that are tardy. So I hope filling that in is pretty easy because it's literally just subtracting and adding. Okay? So now we're going to use that 2A table to show the joint and the marginal frequencies. Okay, so that's what's under here. Now it's going to get a little messy. Let's see if I can make this smaller. Maybe not. Yeah. All right, we'll try. We'll see how this goes. All right. So inside are your joint frequencies, and on the outside are your marginal frequencies, okay? So look back to see how we put that stuff together. So if I look at the frequencies, I'm putting together a fraction. I'm kind of getting ready for that probability, okay? But right now we're not dealing with probability. We're just dealing with the frequencies. So I look at how many people walk and were tardy. That's 22. But 22 out of what? That's out of your overall total, so 130. Now, I have decimals along with that, but I'm not going to be able to fit that in that tiny little box. So you can take 22 divided by 130, and that gets you 0.169, and you can certainly write that down for yours. I'm going to just stick with the fractions, okay? All right, so then how many people walk and are on time? That's 48 out of 130. Okay, so I'm going to mainly focus on my joint frequencies right now. So I'm going to go down to the city bus and how many are tardy. That's 50 out of 130. And then finish with the city bus and on time. That's 10 out of 130. Okay, so when I ask you for the joint frequencies, I want what's in green. When I ask you for the marginal, go outside, but you're still taking it over the overall total. So how many people walked total? That was 70. 70 out of what? 130. How many people took the city bus? 60 out of 130. And then total tardy, 72 out of 130. And how many on time? 58 out of 130. Now don't forget about that very last box. And that very last box should always, always be 1. Why? Because I take 130 out of 130. So it should always be 1 for that very last box. Okay? So that's just putting together your joint frequencies and your marginal frequencies. These are going to help us put together some probability. When I put together that probability, I am going to use the decimals instead of the fractions because I don't want to deal with the fraction divided by a fraction. But remember, I just did not have room to write the decimals. So it might be good for you to jot each of those decimals down, okay? All right, last example. So for financial reasons, the school district is debating about eliminating a computer programming class. The district surveyed parents, students, and teachers. Below are the results of that survey. Here's your two-way table. One thing that is missing, though, you will notice we do not have the totals. So let's take a second and total these up. Okay, so T and T. So this will be 64%, 23%, 13%. I'll kind of separate these two. This should always be 1. This is 24%, and this is 76%. Okay. Just added them up. All right, so now let's look at probability. So what's the probability that a randomly selected parent voted to eliminate the class? Okay, remember one thing from yesterday, from independent and dependent events and conditional probability. If you see the words given that, it's pretty obvious what your A is and what your B is, what your first event and what your second event. Here, there's no given that. So it goes in order. So this is our A, This is our B. Okay? So we're going to look at the probability that they voted yes to eliminate, given that they are a parent. Okay, so what's the probability that they said yes and they are a parent? Well, that's 58%. I don't want the probability that they just said yes. I want the probability that they said yes and they are a parent. That goes on top. So then, what's the probability that they said, what's the probability that they are a parent? That's your probability of A. So that is the 0.64. And you just divide that, and you get 0.906. Okay, take a second, read through the other ones, and then